All right, number 19 um, says ray DF bisects angle EDG. Find FG. Again, so we have an angle bisector. Since we have an angle bisector, we know that these two, that F is equidistant from DG and DE. So these 2n plus 7 equals 2n minus 5. N equals 12. Adding 5 both sides, subtracting. Okay, so they asked us to find FG, so we do 2 times 12, 24 minus 5, which is 19. So FG equals 19. Alright. Number 20 says, how are angle 1 and angle 2 related? They are vertical angles. Vertical angles. 21 says, explain why the triangles are similar, then find the value of x. Well, when they say the triangles, they're talking about this smaller triangle here, 5 and 9, and this larger triangle here. This is x, and this whole side is 15. These triangles are similar because they share this angle by the reflexive property, and then we have parallel lines and corresponding angles, and so they are similar because of angle similarity. Then find x. We can set up a proportion and say 5 to 15 should equal 9 to x. Cross multiply. 5x equals 135. Divide by 5, x should equal 27. Okay. Number 22 says solve the proportion 2x plus 3 over x equals 6 over 5. We can cross multiply. When we cross multiply, we'll get 6x equals 10x plus 15. Subtract that, so we get negative 4x equals 15. Divide by negative 4, and then we'll find that x is 3.75. Negative 3.75. Yep. Alright. Okay. Number 23 says if t is the midpoint of SU, find the value of x and st. So t being the midpoint means that these two should be equal to each other. So I can say 4x equals 3x plus 18. Subtract 3x from both sides. We'll get x equals 18. So x is 18. Find the value of st. St is this spot here. So we have 4 times 18, which gives us 72. So st is 72. Alright. Number 24 says in triangle ACE, G is the centroid. So centroid. BE is 15. They want us to find BG and GE. So they told us that this whole segment is 15. We know that the centroid is cut up into thirds. From the vertex to the centroid is 2/3 of the line, and from the centroid to the side is 1/3 of the line. Okay, so BG is 1/3 of 15. So BG is 5. GE will be 2/3 or the rest of 15. So GE will be 10. Alright. Here we go. Number 25 says list the sides in order from shortest to longest. Remember, the shorter the angle, the shorter the side. So I'm going to look at the smallest angle. My smallest angle is J, so my shortest side will be KL. Okay, my next shortest side will be JL. And then finally, JK. Okay, because it's across from the long side. Number 26, if angle B is congruent to angle C and angle C is congruent to angle D, then using the transitive property of congruence, what conclusions can you make? Well, if B is congruent to C and C is congruent to D, then we can, by the transitive property, say that angle B is congruent to angle D. That is the transitive property. Alright, number 27 says that LO bisects angle NLM. LM is 15, NO is 6, OM is 8. They want us to find this. Okay, this is our triangle angle bisector theorem. Okay, it basically says that the same proportion that these sides of the triangle are divided into is the proportion that the side it divides into is. So, mathematically, we can set this proportion up and say that x over 15 should equal 6 over 8. Cross multiply, 90 equals 8x, divide by 8. 90 divided by 8 will give you 90 divided by 8, 11.25. Okay. It says given that CB is the perpendicular bisector of AD, can you prove that triangle ABC is congruent to triangle DBC using the HL theorem? Okay, so they tell us that the perpendicular bisector of AD, and so as we look at this, they're not asking us to prove it, they're just saying, can we prove it? So, perpendicular bisector means that two things cuts this in half, and it makes 90-degree angles. Okay, so what we can see right now is, hey, we do have right angle, we do have congruent sides here, and we have a shared side. Okay, so right now we could prove it by side angle side. So we could prove that these two triangles are congruent by side angle side. You could reason through and say that because these two sides are the same and this is the right triangle, that these two sides would be the same as well, and so we could use the HL theorem, but using side angle side would be faster. Okay, so that's more of a auditory explanation of that problem than writing it down. Alright, that's that page.